In our second video in this series, we're going to look at the structural representation and naming system for aromatic hydrocarbons, starting with a new name for the central compound of aromatic hydrocarbons, cyclohexane-135-triene. Now, if that name sounds cumbersome to you, the good news is that organic chemists also think so, for which they gave the name benzene to use instead of cyclohexane-135-triene. And the good news about the nomenclature system for aromatic hydrocarbons is that benzene is, for all intents and purposes, the parent chain that we're going to use in every aromatic hydrocarbon that we are going to see. For example, if we take a look at this relatively simple benzene derivative, we can see that there are 1, 2, 3 methyls, so that would be the prefix trimethyl, and because benzene is a ring structure, carbon 1 can technically be anywhere. So if we say that carbon 1 is here, that would mean that the other methyls fall on carbons 3 and carbon 5. And yes, it technically doesn't matter which methyl we choose, because either way, the side chain location number is always going to be lowest at 1, 3, and 5. So this compound would simply be called 1,3,5-trimethyl benzene as our parent chain, which is considerably easier to name than 1,3,5-trimethyl cyclohexane-135-triene. We can just substitute benzene for the name of the parent chain here. Now, if we take a look at the more complicated benzene derivative here, we can see that there are actually 6 different side chains, one on each of the carbons of benzene. So the question is, where do we put carbon 1? Well, actually, it's quite simple. We would put carbon 1 here. Now, even though, because there is a side chain on every single one of the carbons, so the side chain total number is always going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6, but we chose to put carbon 1 here in order to give the first of our side chains alphabetically, that being chloro, the lowest number in terms of side chains. So our alphabetically first side chain would be 1,3-dichloro, because C comes before F for fluoro. In this case, it would be a difluoro because there are 2, and C also comes before E because we have two carbon long side chains, which would be a diethyl. So if we designate carbon 1 as being here to give the alphabetically first side chain the lowest possible number, we would have 1,3-dichloro, followed by, on carbons 2 and 4, we have our diethyl side chains, followed by 5, 6 difluoro, our final 2 side chains on the final 2 carbons, and then we finish it off with the name of the parent chain, benzene. So this is probably the trickiest type of benzene compound to name, because we not only need to take into account the lowest possible side chain number, but we also need to account for which side chain comes alphabetically first in order to designate as the lowest possible carbon number. Now, as with most compounds, drawing benzene compounds from a name is considerably easier than naming a compound from a given benzene structure, and the parent chain being the same pretty much every time simplifies this a great deal. So you'll notice here that I drew the non-resonance form of benzene, and this is correct, or if you were to draw either of the ways to represent the resonance in the benzene ring, this would also be equally correct as well. And all that remains here is to identify where carbon 1 is. Let's just put carbon 1 here, and then we can identify what the side chains are. So on carbons 1 and 3, we have iodos, so substituted iodines like this, and then on carbon 2, which would be here, and carbon 5, which would be 3, 4, 5, right here, we have 2 ring structure side chains, which are 3 carbons long each. So 2 cyclopropyl side chains, which we can go 1, 2, 3, and complete the ring like this. And then again, 1, 2, 3, and complete the ring like this. And lo and behold, we have our 2,5-dicyclopropyl 1,3-diiodo benzene. It's as simple as that. In conclusion, to practice your ability to name benzene compounds as well as to draw the structural representations of benzene compounds, you can take a look at the last practice example here, followed by a series of practice problems here, which will work on your ability to draw and, of course, to name compounds derived from the aromatic hydrocarbon benzene.